Good morning, class. Today we are going to see about the electrochemical series. We have come across this term in our lower classes, class 8, class 9, and we came to know that the arrangement of metals according to their decreasing order of reactivity is known as electrochemical series. Or, in other words, it is also defined as based on the ease with which atoms of metals lose electrons to form positively charged ions, the metals are arranged in a series known as the electrochemical series. So, the arrangement of metals in which it can lose electrons to form positively charged ions in a series is known as the electrochemical series. Okay. Now, we see the table. Electrochemical series of cations and anions. On the left hand side, if you see, so we have arranged the metals according to their decreasing order of reactivity, we can say, starting with potassium, calcium, sodium, magnesium, aluminum, zinc, iron, nickel, tin, lead, hydrogen, copper, mercury, silver, gold, and platinum. So the top metals are highly reactive and the lower metals are highly unreactive. Okay, and the metals at the top can replace the metals at the bottom. Okay, now this metals atom, when they lose electrons, they form a positively charged ion. They are cations. Now if you see the cations, the respective cations, and if you just arrange them in the same order, then they're increasing ease of discharge at cathode, because over here we need to remember the order, because we are doing the chapter electrolysis, and in electrolysis an electrolyte decompose into ions, positive ions and negative ion. Positive ions we call cations, and negative ions we call it as an anion. Now we need to remember the order of their cations. That means which cation will be discharged first at the cathode. Say for example, if in a electrolyte solution, if you have got two cations, say for example, sodium and hydrogen, okay, H plus. Now out of this, which ion will get more preference to go to the cathode? So this can be remembered from this order. So the metals, or sorry, the cations which are at the bottom will be discharged first at the cathode. So according to that, H plus will be discharged at cathode first compared to Na plus. Okay, so the lower the position in the electrochemical series of a cation, it will be discharged first at the cathode. This thing you need to remember. Okay, got it? Now we'll see for electrochemical series of anion for negative ions. Okay, now for negative ions, it is also the same thing. So when we arrange the anions in this order, the lower one, okay, sorry, the lower one, lower the position of an anion in the series, more easily it gets discharged at cathode. So here also it is the same as we see for cations. So the lower in the position of the anion in the electrochemical series, it will be discharged first at anode. Say for example, if you have got sulfate and hydroxyl ion, out of this, OH minus will get more preference to discharge at the anode rather than sulfate. Okay, so just keep this table in your mind, or you can just make a note of this table in your notes. Okay, next, say for example, let us try to understand electrolysis of copper sulfate solution, how the process takes place and what are the different reactions. Okay, just to understand the previous table. Copper sulfate solution. Copper sulfate solution means there is copper sulfate as well as solution means there is a water. So we write down the ionic reaction as, we write the ionic reaction as mm, we write the ionic reaction as copper sulfate giving you copper 2 plus sulfate ion. So it will decompose in that way. It will decompose in that way. Okay. Now water will give as H plus and OH minus ion. Okay. So this is the ionic reactions when the process electrolysis takes place. Now if you see in these two reactions, there are two cations present, Cu2 plus and H plus, Cu2 plus and H plus, Cu2 plus and H plus. Okay. Now I'm talking about this one, Cu2 and H plus. So we have got two cations. Okay. Now and we have got two anions as well, sulfate ion and OH minus ion. Okay. Now there will be a competition between them, since we have got two cations and two anions. So which cation and which anion will go to the cathode and which anion will go to the anode? So since we have got the order before, we can prefer over there. So at cathode, between copper 2 and H plus migrate towards cathode, but only copper 2 plus being lower in the electrochemical series will be discharged. So if you see the electrochemical series, H plus is above and Cu2 plus is below, so the lower position in the electrochemical series will get more preference to discharge. So copper ion will go to the cathode, which will gain electrons and it will convert into a copper. Okay. At anode, similarly, OH minus and sulfate ion both will migrate, both will go to the anode, but only OH minus being lower in the electrochemical series will be discharged. So OH minus lose an electron, it will convert into OH neutral, then 2 OH will convert into hydrogen, sorry, water and oxygen atom, and oxygen atom can combine to form you oxygen. This reaction takes place at the anode. Okay. So this is how electrolysis of copper sulfate solution takes place with the different electrode reactions. Next, electrolysis of molten lead bromide. So in this, let us see. So how we can carry out the electrolysis of molten lead bromide. Molten means fused. Okay, not aqueous solution. Now in this, the electrolyte that is used is a molten lead bromide. Okay, PbBr2. Now we'll take an electrolytic cell is this one, crucible made up of silica. Okay, and in this we have the two electrodes, cathode and anode. Okay, so the cathode and anode both are made up of graphite plates, okay, which are inert. That means they do not react with the solutions. We have got two kinds of electrodes, one is inert and other is active. Okay, inert electrons does not react, and other active electrodes reacts with the, will go into the solution. Okay, so these are inerts. They are connected by copper wires to two ends of a battery. As you know, during electrolysis, the cathode, that is negative electrode, is connected to the negative terminal of a battery. Okay, and the positive electrode, that is this one, is connected to the positive terminal of a battery. Okay, now in this, the ions present, so we have got lead bromide PbR2. So when it decomposes, it will form Pb plus and Br, Pb2 plus and Br minus, lead ions and bromide ions in this. Okay, so what will happen now? The migration will start. Pb2 plus being a positive charge will move to the cathode, and Br minus will move to the anode. Now the electrode reaction that takes place. So at cathode, as I said, Pb2 plus will go and gains 2 electrons to form lead. Okay, whereas Br minus will go to the anode, it will lose an electron and it will form bromine atom, and after that two bromine atoms can combine to form a bromine. Okay, so bromine gas will find at the anode. Okay, so the overall reaction can be shown by this one, PbR2, giving you lead, which is solid, plus bromine gas. Observations, you'll find that dark reddish brown fumes of bromine evolve at the anode, since there is a formation of bromine, whereas silvery gray metal lead is formed on the cathode. Okay, so this is the electrolysis of molten lead bromide. Next, assignment 5. Question number 1 is define electrochemical cities. Question number 2 is draw the table showing increasing ease of discharge of cations at cathode and increasing ease of discharge of anions at anode. So in this you need to draw that two tables from cations and anions, their order. Okay. And question number 3, in the electrolysis of copper sulfate solution, write the correct reaction at cathode and anode using the concept of selective discharge of ions, okay, as I discussed. And question number 4, in the electrolysis of molten lead bromide, mention the following. So in the process of electrolysis of molten lead bromide, just mention this: what is the electrolyte used, what are the electrodes used, electrode reactions at cathode and anode, and observations at anode and cathode. Complete it and send it in my mail.